Okay, everybody, this is still section 3, but now part B, dealing with domain, range, x and y intercepts of functions, and determine values of the function when their graph is given. So the very first thing that we have to look at is this, which is when we are given the graph of a function, just as this one, and we know this is a function because in our minds we can pass the vertical line through the function, and the vertical line is going to intercept this graph in only one x location. So our goal is to find the domain and range of the function. So the way that we're going to do is the following. We're going to look at this function, and I'm going to lower this for this explanation because this explanation is very good. Take a look at this function on the left. Here's the graph, looks like a half a circle. The domain of the function is the set of values from the smallest x value, as you can see here, 1, to the largest value where you can see 7. All right, so the domain of the function is the values on the x-axis from left to right. Now, there's one minor variation. When the points are open like this, it doesn't have to be 2, it could be only on the left or the right. We are going to use parentheses to represent that the final value is not included. We're going to see an example that the final location is included because it's a closed circle. The way that you see it over here, it's a open circle. So if it's an open circle on the left or the right or both, we'll use parentheses. And in this case, since the smallest value is 1, the largest value is 7 on the x-axis, we write the domain this way. The range is exactly the same thing, except that we're going to go from bottom to top or top to bottom, doesn't matter. Just keep in mind that the answer has to be written from the smallest y to the largest y. So that's why we're saying bottom to top. So we're going to look at this graph right here that I have on the right, on the left, I'm sorry. And we're going to find the smallest y coordinate. And the smallest y coordinate is 0, right? Because it's exactly on the x-axis. And then we're going to find the largest y coordinate, and I can see on the very top of the circle, the value is 3. So we'll say that the range is from 0 to 3. So now I have to determine if the endpoints are included or not. If they're not included, like in the graph, because of the open circle, I will use parentheses. If it is included, like on the 3, I don't see an open circle, I'll use the square bracket. So this is how you find domain and range on a function when its graph is given. So let's take a look at an example. I guess before we do the example, let's go over, this is very quick, the intercepts. So every function is going to have at most 2 intercepts. It may be that there are no intercepts, no x, no y. So the x-intercept is the coordinate of the point where the graph intersects the x-axis. That's why we call it x-intercept. And likewise, the y-intercept is the location on the graph where the function intersects or crosses the y-axis. So it's very easy. All we have to do is find the location and include the point itself. Now, these points are always going to be stated in parentheses, okay? Never a bracket. So in this case, take a look at the graph. The x-intercept is right here. I have 2 x-intercepts. Look at the x-axis. The graph of this parabola crosses at -2, 0, and 2, 0 on the right. So we have 2. The y-intercept is the location the graph crosses the y-axis right here in the middle, and the location is 0, 4. Now keep in mind the coordinates are always written x first and y second. So that's why the coordinate is 0, -4. Okay, so these are the two things we have to do for the second part of our section 3. I'm going to go over two examples now to walk you through, and I think I am going to show you these two examples. They're very quick. And right here, I copied the graph. So let's take a look at the first example. Our goal is to first find, maybe let's find the x and y intercept. So I'm going to abbreviate it x-intercept and then y-intercept. Okay, so the x-intercept again is the location where the graph crosses the x-axis. So it's right here at this location. Okay, so let me just erase that so that you can see. So the location seems to be -1/2. So you would write -1/2, comma, y0. Okay, now this location here, because it's an open circle, the graph is not really touching there. So this is not an x-intercept. Okay, if it was a solid point, it would be 2, 0, because it's right here at 2 and the y coordinate is 0. The y-intercept is this location right here. Okay, so the y-intercept has coordinate 0, -3. Remember, the very first coordinate is x, the second coordinate is y. Now, let's find the domain. And let's find the range. So again, the domain is going from left to right. So I'm going to find out the smallest x coordinate. So this is as low as the x coordinate go right here, right? There's nothing after this point. There's nothing here. This is all empty. So this is out of the domain. So it goes from here all the way up to 2. So you're going to write -3, 2. So now the question is, do I use parentheses? Do I use bracket? Okay. Let me just erase this. I don't want that thing here. So it goes from here to here. So here's my -3, 2. And notice that at -3, the point is solid. So I'll use a bracket. But at 2, it's an open circle. So I use parentheses. All right, very good. Let me just erase this. And now I have to find the domain. So the domain is the same thing, but now I go from top to bottom on the y-axis. So this is the smallest y, which is -3. It's just a coincidence that they both are -3. And the highest y that I have is 5. There is nothing above 5. So I'm going to write 5 right here. So you write the two numbers. And now you determine if it's a closed or open. So in this case, look at both cases. Look at both cases. I don't have an open circle at -3 down here, and I don't have an open circle at 5. So they are both square brackets. Okay, great. Now, second example, let's take a look at the x-intercept and y-intercept again. In this case, both x and y-intercept are right here. The graph only crosses this location once. So the x-intercept is at the origin 0, 0. And remember, the x and y-intercept, always you use parentheses. So both of them are at 0, 0. The graph only crosses the x and y at that single location. Let's take a look at the domain. And let's take a look at the range. So again, the domain, we go from left to right on the function. So we get the smallest x. So notice I see an arrow here. What does that mean? This means that it means that the graph keeps on going here forever. It doesn't stop. It keeps on going and it keeps on going and it keeps on going. So when that happens, when you see an arrow, in this case, the arrow is going to the negative side, you're going to write negative infinity. It doesn't stop. On the right side, the graph stops right here at 8. So you're going to write 8 over here. And now I look at 8. This is a closed point. I use bracket. And the positive or negative infinity, whichever case it is, you always use parentheses, never a bracket. Okay? Because it can go lower and lower and lower, or in another case, higher and higher and higher. All right, so that's the domain. How about the range? So let me just erase this again. So again, for the range, I go from top to bottom. The smallest y I have is again at this location, at 0. So I'm going to write 0 here. And I need now to find the largest y. So at first impression, I might think that this is the largest y, 6. But keep in mind, this arrow keeps on going forever, right? So right now is 8. If I go a little higher, maybe 10. If I go a little higher, 12. So it goes on forever. So you have to write infinity over here. Infinity, positive and negative, is always a parentheses. And on the 0, because this is a closed point, there is no open circle. We use square bracket. Okay, so this is the range for that particular problem. So this is how we find x and y intercept on a graph and domain and range. So let's go back to section 3 and let's go over the very last thing that we have to do. It's nothing new, but now you're going to be given a graph like this one, and we have to find the values of the graph. So in the first case, we have to find the y coordinate associated with these x values. These two values here are the x values. And in the next two cases, we are given the y value and we have to find the x. So take a look at the graph on the right. So how do we do the first problem? So you're going to go to x equals 2. And then you're going to go to find the question mark, which is the y coordinate. You're going to go, in this case, down to where the graph is. When you do, you're going to write the y coordinate for that particular location, which in this case is -3. Okay, right here. For the 0, you go to x equals 0. And then for the question mark, you go where the graph is, which is right here at 4. So f of 0 is 4. Okay? When you do the reverse, you need to find the x value that the y coordinate is 6. So you go to where y is 6 on the graph, which is up here. And then you get the x coordinate, which is -1. Okay? So when x is -1, the function is 6. Same thing for -3. Go to y equals -3. And then you will be able to see here there are two values for which the function has a y equals -3, which is 2 and 3. Okay, so then we can write when f of x is 2, when x is 2, f of 2 is -3, and when f is 3, f of x is -3. Okay, and we'll discuss this in a minute when we see a problem. So again, let's take a look at these two values. So I think I'm going to do this function here and the last function for you guys. So let's take a look at our examples in here. So let's do the first one first. So we'll find the domain of the first function, just as we did before. And then the domain is from the smallest x -5 to the highest x, which is 0. And on the -5, it's closed. On the 0, it's open. So here is the domain. For the range, we do the same thing, but from top to bottom. So the smallest y is -4. And the largest y is 8. At -4, the point is closed. At 8, the point is open. Okay, so that's good. Now let's see if we find f of -5. So you go to -5 for the x, which is right here. Go where the graph of the function is and pick out the y coordinate, which is -4. Okay. Now we do the reverse. We need to find the x when y equals 6. So you go to y equals 6, right here. Go to where the function is and grab the x coordinate, which seems to be right here in the middle. So I would say x equals -1.5. All right, and then the last question here is determine the coordinates of the x and y intercept. So let's take a look at that. So here is the x-intercept. This is where the graph crosses the x-axis. So that would be x-intercept -4, 0. And the y-intercept is where the graph crosses the y-axis. It's right here. Now, because of the open circle, it never touches the y-axis. So you can say none or does not exist. Okay? If it was closed, if the point was closed, you would write 0, 8. But it's not. It just doesn't exist. Okay, very good. So last example, which is, I think, is this one that I have for everybody. Let's make it a little bigger for everybody to see. All right. Erase this thing over here. And let's do the whole thing again. So let's first find the domain of the function. Maybe let's see if it's maybe a little too small. And notice that for the domain, there's an arrow here, right? So this keeps on going forever. So it goes on forever. The smallest value is -infinity for the x. And then the largest x is right here, which is the number 5. Now I need the parentheses or bracket. At 5 is closed. And as I told you before, positive or negative infinity is always parentheses. For the range, same thing, but now we do it on the y-axis. So from top to bottom, here's the smallest y at -3. And it is a solid point, so it's closed. And the largest y, notice the largest y is not 4. It keeps on going until it gets to 8. And it is also closed. So here's the range. right? We evaluate these two values. I go to negative 4x, and I go to where the function is, right here. And this point, I pick the y coordinate. Same thing for the 1. You go to x equals 1 is, you go to where the graph is at 1, and then you pick the y coordinate. Okay? Now we do the reverse. I need to go to y equals 5. I go to y equals 5 right here and go to where the graph is. And then I pick this x coordinate. All right. X and y intercepts. Again, the x-intercept are the locations where the graph crosses the x-axis, which is this one right here, and this one right there. So I think you can see in both cases, negative 2, 0, 2, 0. And the y-intercept is where the graph crosses the y-axis. 0, negative 3. All right. If there is a y-intercept, there is going to be only one. There may be multiple x-intercepts, maybe 1, 2, or more. But if there is a y, there's only going to be one y. And the last thing in this particular question is we need to find for what values of x, y is negative. So notice that y is negative only in this section right here. Okay, so every value of x in here is negative. So it's going from negative 2 to 2, not including the endpoints. So parentheses on both cases, minus 2 to 2. The reason it does include the endpoints is because if it does, the value of the function would be 0. Okay, so this is how you find the domain and range, x and y intercept, and evaluate the function at these points according to these questions.